So for part B is where they're asking us to evaluate the integral from 3 to 5 of 2 f prime of x plus 4. So this is where I'm going to use that idea that I know the integral from 3 to 5 of f prime of x is just going to be f of 3 minus f of 5 minus f of 3. That's just fundamental theorem of calculus. But the trick is I need to isolate this f prime, and that's part of what this question is about is you know, we've really in this part A, when we're manipulating integrals like this is all just about properties of integrals. What can you do with an integral? So when, you know I can break up the interval like that. Another thing I know I can do is break up the integral over plus sign and pull out a constant multiplier. So we'll just rewrite this, and I'm going to use several steps. You could do this in one step if you want. This is the integral from 3 to 5 of 2 f prime of x dx plus the integral from 3 to 5 of 4 dx. Okay, and then I'll pull out the 2. So 2 integral from 3 to 5 of f prime of x dx. Now, this integral, you should be able to just look at that and say it's 8. So if you don't look at that right away and see it's 8, it's worth taking a little bit of time to talk about, you know, an integral like this where I just have the integral of a constant. So, all right, you can do the antiderivative as 4x, and then you plug in the 5 and you plug in the 3 and you subtract, all right, that's fine. But like if you think geometrically, this means I have a constant function whose value is 4, and I'm going from 3 to 5. So that's a rectangle that's 2 by 4, and 2 times 4 is 8. And you can sort of generalize from that in general, if I have the integral from a to b of a constant, then that's just going to be k times b minus a. Right, so if I see an integral of a constant, I'm just going to, well, the difference between 5 and 3 is 2, 4 times 2 is 8, so that integral is 8. But if you want, you know, do the whole antiderivative and everything. All right, now once I'm here, I can say, okay, this is fundamental theorem of calculus. If f is an antiderivative of f prime, so I can say that this is f of 5 minus f of 3, and then I have my plus 8. So then I just look at the graph, because I have a graph of f. Right? My graph is not of f prime, my graph is of f. So I can see, oh, I know what f of 5 is, it's 0. So for f of 5, I can put 0. And then when I go to do f of 3, I say, oh, it's not obvious what f of 3 is. So I could use the fact that this is a circle. I know what the center is. I could get the equation of the circle, blah, 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 blah. But they're not usually going to make you do a lot of calculation like that. They like to be more conceptual. And that's why they told you that the point 3 minus square root 5 is on the graph. So look for them to give you something like that. We already know what f of 3 is just from here. It's 3 minus square root of 5. So for my f of 3, I can put 3 minus square root 5. And then I can close that and put plus 8. Now I am done. So this is actually a classic example of I don't need this result for anything coming up in the future. There's no reason at all for me to simplify this. I would be likely to make a mistake simplifying it, so I should just leave it like that. Now, if you can't help yourself, as I sometimes can't, it's 2 plus 2 square root of 5. But you should just leave it like that for the BC exam.